All right, Bismillahirrahmanirrahim. Assalamu alaikum students. Let's solve this problem which is related to chapter 5 and the subtopic is 3D supports, a very challenging and basically numerical. And if you look at it, the problem says that both pulleys are fixed to the shaft. Okay, you have got one pulley, this is pulley A. Okay, the blue one is the pulley A and the other blue one is the pulley B, and on these pulleys basically this long bar is called as the shaft. Okay, so and as the shaft is basically rotating with constant angular velocity, it is rotating with a constant angular velocity. Okay, and basically the power of the along with the power of the pulley A. Okay, it is rotating because of this power of this pulley A. Okay, and is transmitted to pulley B. So the rotation of this pulley A is being transmitted to this pulley B. Okay, this means that this pulley is the driver pulley and this is being driven by it. Determine the horizontal tension T. You need to calculate the horizontal tension T in the belt of the pulley B. Okay, you need to calculate this horizontal tension T in the belt of this pulley B. Okay, then he says and the XYZ components of reactions at the journal bearing C. He says you need to calculate XYZ components of reactions at the journal bearing C. Okay, so this is very important. He's telling you about the journal bearing. Where is the object? This is journal bearing, and what is he saying? The XYZ components. Okay, the XYZ components. Okay, these are your XYZ components of the reaction at the journal bearing C, and he's also asking you that there is a thrust bearing. There is a thrust bearing over here. Okay, thrust bearing is also being placed at point D, and he says that this pulley B, there is a theta defined, that this theta equal to 0, because if you look at it, this belt which has a force of 50 Newton is making some angle along the y-axis, but he is making your life easy right now in this problem by telling you that this theta is basically if it is 0, this theta is 0, it is not at any angle. The bearings are in proper alignment and exerts force reactions on the shaft. He is again telling you a very important thing, that the bearings are in proper alignment and exerts only force reactions on the shaft. This is very important to understand this problem. Here you have basically the journal bearing. Okay, the C is basically the journal bearing and D is the thrust bearing. Okay, you know it very well. This is the journal bearing. This is the journal bearing. Okay, this is your journal bearing, and this D is your thrust bearing. This is, if you look at it, you can say this is your you can say that this is your I will make symbolizes that this is your thrust bearing. This is your thrust bearing. Okay, now you have to basically go and understand what journal bearing and thrust bearing reactions they actually give in the real life. Okay, so if you go here and you see, this is your journal bearing. This is your journal bearing, and he says to you that the journal bearing has 4 unknowns. the reactions are two force and two couple moments which acts perpendicular to shaft. So 4 reactions, 1, 2, 3, 4. Okay, there are 4 reactions, 4 unknowns. But he says the couple moments are generally not applied if the body is supported elsewhere. So he says there are 4 unknowns, but these couple moments will not be applied for the journal bearing. One point. The other point, if you go to this thrust bearing, single thrust bearing, it gives you 5 unknowns. The reactions are 3 forces and 2 couple moments, but he also says the couple moments are generally not applied if the body is supported elsewhere. Okay, so this is very important. So here we will have only 3 reactions, but not a couple moments. And here, when we say in the thrust bearing, he says, okay, 3 reactions we will consider, and when the general bearing is there, you know you have 4 unknowns, but you will not consider the couple moments, so you will have 2 reactions. So with this knowledge in mind, when we go to this numerical, we will look at this general bearing and we will see they are only giving us 2 reactions, not 4. Now you go to this thrust bearing, and from this FBD we can easily see we will not get 5 unknowns, we will get 3 unknowns, dx, dy, dz, and no 2 couple moments. So this is the mechanics that is very important, the reactive components of the journal bearing and the thrust bearing. How do you get these 2 unknowns and 3 unknowns over here? If you understand this, now the problem will be comparatively easy for you, because you know what, if you look at it, if there are 4 unknowns over here, okay, and if you look at it, there are 5 unknowns here, so 5 plus 4 is basically 9 unknowns, and if we take this t also along with it, so there will be total 10 unknowns. Okay, so if there will be how many unknowns? There will be 10. There will be 10 unknowns. Okay, so and you can see this is a 3D problem, so you will have 6 equations of equilibrium. So in the maximum equations that you can form will be 6, but the unknowns are 10. So this system cannot be solved. No way in the world you can solve this system with these conditions, because you have only 6 equations of equilibrium in this subject of statics. So by taking, if you look at it, if you basically say there are 2 unknowns here, there is 1 unknown here, 3, and you can say there are 3 unknowns here, it will make 6 unknowns. So by this condition, over here is 1 unknown, 2 unknown, 3 unknown, 4 unknown, 5 unknown, and this one dz, 6 unknowns. 6 equations of equilibrium, 6 unknowns. So life is very easy. Now you can basically solve this problem because everything is being understood. Okay, so let's start solving this problem. Okay, so first of all, what we will do summation of all the moments about the x-axis. Okay, we'll start by summing of all the forces about the x-axis. So what does that mean? It means that what will be the forces that will be summed along the x-axis. Okay, so it will be this force, okay, 65 Newton, then the 80 Newton force will be summed. Okay, then you can take the moment, then this force moment can be taken, okay, very easily. Okay, and basically if you look at it, this cy and cz basically not be considered because they are passing through this x-axis. Okay, so let's start solving the problem. So if you look at it here, we will say summation of all the forces about summation of all the moments about x-axis is going to be equal to 0. Okay, so then now we will say there are 65 Newton force. Okay, this 65 Newton force and 80 Newton force, if you look at it here, okay, first of all consider this. These force 65 and 80 Newton forces are along the z-axis. Okay, and it has basically a radius of 0.08 meter. Okay, so when it has a radius of 0.80 meter, so we can easily say that this radius, if you can see from here, it can be this radius which is along the, if you look, it will be along the y-axis. Okay, so we will say that it will be 65, we will say it will be 65, and what is the radius? If you look at it, it is going to be 0.08. Okay, then if you look at this 65 into 0.08 radius on both sides, if you look at it, this one also, and you can say this also. Okay, so this 65 into 0.08, 65 Newton is along the z-axis and 0.08 is along the y-axis. It has the tendency that it will basically be rotating the body in the 65 Newton to 0.08 in the anti-clockwise direction about the x-axis. So it is going to be plus. Now if you look at it, there is another force, this 80 Newton. So this is also along the z-axis, and its moment arm, which is the radius of 0.08, is along the y-axis. But this 80 Newton force, when you rotate about this x-axis, okay, which is this is our x-axis. You can always say this is rotating. This is about this axis. This 80 Newton force rotating about this x-axis will basically be a clockwise rotation, and you know clockwise movement is always going to be negative. So you will write minus 80 into 0.08. If I'm not, 0.08 is the radius. Okay, then you go to the other force, which is this one, the T force, which is along the y-axis. And what is the radius of this force? You can easily say it is 0.15 meter along the z-axis. Okay, T is basically along the y-axis, and the radius is along the momentum radius are one and the same thing, is along the z-axis. So you can say this force T into 0.5, if you look at it about the x-axis, is going to rotate the body. This force is, and this is again, if you want, you can make this about, again, this is the axis right now, this is the axis. So this force along the y-axis and the radius is along the z-axis is going to rotate the body in the anti-clockwise sense. So we can easily write here as plus, we can write it as plus T into 0.15. okay, now we go to other force, which is the 50 Newton force. Okay, this 50 Newton force, if you look at it very clearly, it is again along the y-axis, and you can make its radius as 0.1 meter along the z-axis. But this is our axis, this red line is the x-axis. So you can easily say that this 50 Newton force with the radius and momentum 0.15 is going to rotate in a clockwise sense. So when it is going to rotate in a clockwise sense, you can very easily say that it is going to be 50 into 0.15. But this rotation is, since along the it's clockwise rotation, so it is going to be equal to 0. So this is the summation of all the moments about the x-axis, equal to 0. Okay, and we assume our standard assumption that the anti-clockwise movement, you can say the anti-clockwise movement is always going to be, you can assume, again this is an assumption, you can assume anti-clockwise movement is going to be the positive movement. Okay, and again now we will basically be going to our summation of all the moments about the y-axis. Alright, let's start with the summation of moments about y-axis. But first, before starting, this is already, you know it very well, but you know this is your positive x. Okay, and this is going to be your positive y, sorry, positive z, and this is, remember, this is going to be your positive y-axis. Okay, this is going to be your positive x, positive z, positive y. This is your negative y. This is your negative y. Okay, you must remember this. Okay, so now we basically start the summation of moments about the y-axis. summation of moments about the y-axis is equal to 0. Okay, and I was saying anti-clockwise moment will always be positive. Okay, so if you look at it here again, you need to sum all the forces, basically moment forces about the y-axis. Okay, so if you look at it, this force T and this force 50 are along the y-axis, so they will automatically be no movement for those forces along the y-axis. Dx, dy, dz are the forces along the, basically they have no momentum as they are passing through the y-axis. Okay, so basically again they will be nullified, there will be no momentum. Okay, again if you look at it, this cy is basically along the y-axis, so there will be no momentum. So basically you will be left with this force 65 Newton, 80 Newton force and this CZ force. Okay, to calculate the moment about the y-axis. So once this is done, let's see how we basically calculate it. Okay, so if you look, this force 65 Newton, okay, this is along the z-axis. Okay, this 65 Newton force is along the z-axis, and basically its distance along the its moment arm will be 0.08 meter. Okay, and that moment arm will be along the x-axis. That moment arm will be along the x-axis. Okay, so you can say basically say 65 Newton basically, and its moment arm basically along the x-axis will be, sorry, it will be 0.25. This 65 Newton into 0.25 into 0.2. 65 Newton is along the z-axis, and this 0.25 plus 0.2 moment is the moment arm along the x-axis. And the same with this 80 Newton force which is acting along the z-axis, same sense, and the moment arm again will be 0.25 meters plus 0.2 meters. Okay, this is going to be the moment arm along the x-axis. So forces along the z-axis, moment arm is along the x-axis. The rotation, basically the moment will be about, the moment rotation will be about the y-axis. Okay, so now if this is understood, we can basically write it as over here. We can write it as 65. Okay, 65 into 0.45, 65 into 0.45. Okay, and we can also write it as 80 into 0.45. Okay, we can write it as 65 into 0.45 plus 80 into 0.45. Okay, and why are these moments positive? That is the next question which is in all of our minds. Okay, if you again look at the picture, this 65 Newton force on the z-axis and this 0.45 along the x-axis will basically be rotating the body. It will rotating the body. This is along the, if you can see, it will be rotating the body about the y-axis. This force is going to rotate the body about the y-axis. Okay, you can easily say this is the axis, it will rotate about the y-axis, but the sense will be anti-clockwise. The sense will be anti-clockwise. So that is the reason. Basically, and if you want for your own good, we can make it as this is our y-axis. Okay, this is our y-axis. Okay, so this force is going to rotate the body. So it's going to rotate the body this force is going to rotate the body in this sense. Okay, in this sense, and this area, your y-axis is just like this. Okay, so it will be anti-clockwise. So that is the reason they are basically treated as positive. And what about the other force we have? This force CZ. Okay, this CZ is along the z-axis, and again the moment of this force will be till this point is going to be, till the origin is 0.3 meter plus 0.25 meter, 0.2 meter. Okay, so what we will be write here, if you look at it, you can say it will be again, if you look at it, this moment is going to be minus cz into 0.4 not 4, it's going to be 0.75. Okay, so why is the minus sign, and it will going to be equal to 0. Okay, so why is the minus sign over here? The minus sign is here is because if you look at it, this is cz, this cz word on the z-axis, and this 0.75 is along the x-axis. You can easily say this cz has a tendency to rotate the body in a clockwise sense about this y-axis. So from here you can calculate your cz very easily. Okay, your cz, because all are numerical values, so cz comes out to be equal to 0.87 Newton. Okay, if you calculate, it is going to be 87 Newton. And the other one way over here is basically from here in this equation, when we are calculating sigma x, you could have calculated your t comes out to be, because all numerical values are known over here except t, so here you can say t was equal to 58 Newton. So you've got t, you've got cz calculated. Okay, now basically your other task will be to calculate the summation of all the moments about the z-axis. Okay, summation of all the moments about the z-axis. So let's make it more conspicuous. We rub this off so that we can make more. Alright, let's start solving and calculate the moment about the z-axis. Okay, so if you look at it, this is going to be summation of all the moments about the z-axis must be equal to 0. The same logic, we'll write it as this is going to be positive, the anti-clockwise. So if you look at it here, when we summing moments about the z-axis, okay, this force 65 and 80 Newton is along the z-axis, they will be nullified. dx, dy and dz are all passing through the z-axis, so there will be no momentum. Okay, and if you look at it, this because cz is along the z-axis, so there will be no respective momentum. So I think the respective forces that will be involved is this force 50 Newton, T, and your respective Cy. Okay, so let's sum the moments about the z-axis. Okay, if you look, the 50 Newton force and this T force has the same sense along the negative y-axis. Okay, if you look at it, it has the same sense along the negative y-axis. Okay, and basically your respective momentum, because these are along the y-axis and the momentum is along the x-axis, so the rotation will be along the z-axis. So we will, if we understand this, we can easily calculate this equation, our equation, just because of the same sense we can simplify our equation as 50 Newton. Okay, it will be 50 Newton force into the momentum is 0.2, again plus, because they are taking the body in the anti-clockwise direction when respect to the z-axis, you can easily see. And the other one is basically T was calculated as 58 Newton, so it will be again 58 into 0.2. This is calculated now. Once this is done, what about the Cy force? If you look at it, this Cy force, Cy is along the y-axis, the positive y-axis, and the momentum will be, this is y-axis and the momentum is along the x-axis 0.3 meter 0.2, add 0.25 meter and 0.2, it will be again I think 0.75. But from the z-axis, if you look at it, this Cy force from the it is going to take, and this is the z-axis, this Cy force is going to take the body in the clockwise sense. If you look at it, it's going to take the body about the z-axis in a clockwise sense. So now it will be, it can be easily be written as Cy into 0.75, 0.75, okay, 0.75, and it must be equal to 0, and since it is clockwise, so you will write a negative sign here. So this equation has been made. If you look at it, you know all the mathematical quantities except the Cy, so you can calculate Cy very easily, as Cy comes out to be equal to 28.8 Newton. Okay, so this is also being calculated. Now you have to calculate basically you have calculated T, you have calculated Cy, okay, and if you look at it, you have also calculated your Cz. What you are being left up with now is basically dx, dy and dz. Okay, I think the easiest one is coming if we basically sum all the forces about the x-axis here. If we sum all these forces about the x-axis equal to 0, okay, if we sum, so you see d, is there any force which is along the x-axis? I think there is only one force which is along the x-axis, and we will write it as dx. This is the force dx, and I think there is no other force apart from dx, so it automatically becomes dx equal to 0. Okay, so this is also being done. Now we basically go and we need to calculate dy. We need to calculate dy. Okay, so let's calculate basically dy. For that we have to calculate, we have to sum forces about the y-axis. Okay, sigma Fy is equal to 0. Okay, sigma Fy equal to 0, which means sum all the forces along the y-axis. Okay, so if you sum the forces along the y-axis, you can see what are the forces which are along the y-axis. You can see this 50 Newton force is along the y-axis, this T Newton force is along the y-axis. Okay, but you have to make the sense very clear. This is minus y, okay, that is plus y. And what about the other force which is along the y-axis? It is this Cy force which is along the y-axis, and the unknown dy. Okay, so altogether if you look at, you have basically 4 quantities along the y-axis. Okay, so let's try to calculate these quantities here. Sigma Fy equal to 0. Okay, for our ease of calculation, we can so that it is better understood by all of us. Okay. Now let's, so that the figure is in front of us. Okay. Let's apply sigma Fy. So sigma, when we apply sigma Fy, this dy is along the, remember, positive y, so it will be dy. What are the other forces that we have here is basically T and minus 50. Okay, if you look at it, minus 50, minus 58. What are these forces? This one, T was 58 and this is 50 in the negative y-axis. Okay, and what about this Cy that you calculated? It is towards the positive y-axis. Okay, so it was calculated as, you know, from the top, it is plus 28.8 is equal to 0. So from here you can say that dy can easily be calculated as, if you, all numerical values are there except dy, so equation is very simple. You will calculate this dy as 79.2 Newton. Once this is done, okay, now you are left with sigma fx has been calculated, sigma fy has been calculated. Now we can go and calculate sigma fz also. Sigma fz is equal to 0. Okay, once you calculate this sigma fz, you know what are the quantities that you have here. Okay, for the fz it is going to be this one quantity cz, then these two 65 newton, 80 newton, so 1 2 3, and then dz itself, this quantity you see dz over here. Okay, so once when you calculated it, you will get it here, just for ease of, okay, so what will be going to be the value over here for, we will have the first unknown as dz. Dz will be the unknown. Okay, what is the other known? Basically that you've calculated along the z-axis, that you have calculated is cz. Cz is going to be, which is how much? 87. Cz is basically how much? 87, if I am not wrong. How much was cz? Yes, cz was 87, and the sense is, again it is plus. If you look at it, the sense is going to be plus because it is acting towards the positive y-axis. What are the other quantities you have? It is the 65 newton and the 80 newton, but you see here they are all in the negative z-axis. So minus 65 minus 80 is equal to 0. So now you can say the whole equation is, you know, the all numerical values except the dz. So you get your dz calculated as, comes out to be equals to 58 newton. And you can see that this was numerical. Okay. There is no good here. This is calculation. Okay. So you have calculated the unknowns of this system very easily. Okay, you have calculated the unknowns. You have calculated. You can see you calculated t. You have calculated by saying sigma, calculating sigma x equal to 0. You calculated y cz by calculating sigma my equal to 0. Then you calculated cy by calculating summation of moments about the z-axis equal to 0. Through sigma fx you calculate dx equal to 0, and then you calculated from sigma fy, by doing sigma fy equal to 0 you calculated dy, and by doing sigma fz equal to 0 you calculated your dz. So this numerical was a very quite interesting and numerical, in which you would have learned a lot, and I hope you have understood the main facts about this numerical. Okay, and all right, thank you very much. I shall see you with more numericals, and make sure you subscribe to my channel so that all the latest videos of statics will basically be increasing and enhancing your knowledge. Okay, thank you very much.